Good afternoon everyone. Today we will explore the incredible and amazing universal law of gravitation. We'll delve into how this law explains the force of attraction between two objects in the universe and how this understanding has shaped advancements in science, technology, and engineering. So let's get started. Gravity is one of the most basic physical forces that is responsible for a variety of physical phenomena. Both attractive and repulsive forces between objects are caused by gravity. On Earth, the force of gravity affects the movement of planets, Earth's rotation, and attraction of objects towards the ground. In outer space, this force influences the motion of galaxies, planets, and other bodies in the solar system. The universal law of gravity states that the strength of the gravitational force between two objects is directly related to the mass of both objects and the distance between them. Centripetal force is another type of force that keeps objects moving in a circular path, and it acts towards the center of the circle. This force can be seen in the movement of planets in elliptical orbits, the movement of electrons around a nucleus, etc. The universal law of gravitation states that the attraction between two objects is proportional to the product of their masses and inversely proportional to the square of the distance between them. This can be expressed mathematically as F alpha mxm, with F being the force of attraction, m and m being the object's masses and d being the distance between them. By cross-multiplying this equation, we can determine the constant of proportionality, which is known as the universal gravitation constant and has a value of 6.673 x 10 to 11 nm 2 kg2. Through understanding this law, we can gain insight into the forces that shape the universe and how they interact with each other. Objects in the universe attract each other due to their mass as per the universal law of gravitation. On or near the Earth's surface, the gravitational force is why objects fall towards the Earth. Such acceleration is referred to as acceleration due to gravity, given as g and equal to the product of the mass of the Earth, the distance between the object and the Earth, and the square of the Earth's radius. The acceleration due to gravity on the surface of the Earth is 9.8 meters per second squared. A body's mass is indicative of its inertia. It stays the same regardless of location and is measured in kilograms. Weight, on the other hand, is the force with which the Earth draws the body, which is found by multiplying the body's mass with the force of gravity, depending on the place. This force is then measured in Newton. Therefore, weight is not fixed and may be different in different places, while mass stays the same. The mass of the Moon relative to the Earth is what determines the weight of an object on the Moon. The Moon has a much smaller mass than the Earth and as such exerts a much weaker gravitational force. This can be seen in the data table, where the mass of the Moon is only about 1/6 of the mass of the Earth. Consequently, the weight of an object on the Moon will be 1/6 of its weight on Earth. Thrust is a force that acts on an object perpendicular to a surface. Pressure is the force that acts on a unit area of a surface. Both thrust and pressure are related to the force of an object on a surface. When standing on loose sand, the weight of a person's body acts on an area equal to the size of their feet, whereas when lying down, the same force acts on an area equal to the contact area of the entire body. In either case, the force acting on the sand is the same. However, the effect of thrust on loose sand is greater when standing than when lying down. The SI unit of thrust is Pascal, or N per square meter. Fluids possess great power and should not be underestimated. Pressure is transmitted evenly throughout liquids and gases across a container. This is linked to buoyancy or upthrust, which is the upward force an object experiences when submerged in a fluid. This buoyant force is determined by the density of the fluid, with greater density resulting in greater buoyancy. Gravity pulls the object downwards, while buoyancy pushes it upward, until a balance is reached which allows the object to float on the surface of the fluid. Objects with different physical properties will behave differently when placed in water. The denser an object is relative to the water it is placed in, the more likely it is to sink. On the contrary, an object with a lower density than the water it is placed in will tend to float. To illustrate this, let's consider two objects of the same mass, a piece of cork and an iron nail. When placed in a beaker of water, the cork will float because its density is lower than that of the water. The iron nail will sink, due to its greater density compared to the water. The upthrust of the water, which is the buoyant force that pushes the objects upwards, is proportional to the density of the object, and less than the weight of the iron nail, thus causing it to sink. Archimedes' principle states that a body placed in a fluid experiences an upward force which is equal to the weight of the fluid displaced by it. This principle is applied in areas such as ship and submarine design, hydrometers used to measure liquid density, and lactometers used to measure milk purity. It is also useful in understanding how an object behaves when submerged in a fluid, and is essential to understanding how objects interact in the universe.